Thank you for the opportunity to speak with you today. I will be presenting what I consider to be a really exciting opportunity for our school. As you are all aware, we have a capital project on the horizon in which we will be extending our existing facilities. The addition to our building could be used for a variety of possible functions. And there are a lot of options on the table. But today I would like to present to you something that I think is an exciting and transformative possibility for this new addition. As you know, we are keen as a school in preparing our students for both fulfilling careers and fulfilling lives. Our motto, non scholae sed vitae, not for school, but for life, has been a guiding principle for any of our program decisions in the past. I would argue that we should continue to use this as our guide as we make decisions going forward. We should be making sure that any space that is added to the school gives our students an opportunity to develop the skills and the abilities that will be important for the 21st century. There have been many educational reforms over the years. Some of them have been nothing but hype. Others have dramatically changed our view on how teaching practices should look. I would argue that the current maker movement can be a transformative way of changing how our students learn. The idea of making is that students actually construct, build, design in an effort to solve a problem or accomplish a task. In the process of making, students develop personal connections and take ownership of what they are learning. Also, in making ventures, there are real-world problems, real-world challenges that they have to try to solve or overcome. That makes this sort of learning authentic and gives the students a strong sense of this is worthwhile and has meaning. Furthermore, over the last several years, curriculum redesigns have been implementing more engineering and design elements, such as Next Generation Science Standards, NGSS. They have actually incorporated the idea of the iterative engineering design process into a lot of this new science standards, something that New York State is adopting over the next few years. As a result, we want our students to have a certain level of engineering literacy. In other words, using design to, again, solve problems and overcome challenges. Furthermore, there has been a strong push in high school education to include computational thinking in the curriculum. We've seen that here at Malloy as we've begun to employ more and more computer science courses, whether that's the AP level or our robotics course, etc. So ultimately, we want to be making sure that students have a space in which they can encounter learning of this type, because it is a powerful way for students to develop deep conceptual understanding and see learning as exploration and play. This sort of learning can only happen in a space that has been designed to allow students to explore, build, and be creative. That's why I propose that the addition to our facilities should be a makerspace. This would be a multi-purpose room equipped with tools and a collaborative space that would allow students to explore, create, and collaborate. Such a makerspace would accommodate a wide variety of courses, including introducing a new course at Malloy called Engineering and Design, in which students would be tasked with constructing devices to accomplish various goals. That could include building balsa bridges or designing some sort of robot. We could also use that space to allow us to expand and grow our computer science program. Given the small space that we currently have for CS courses and the increase in popularity by the student body, we will need another place for CS to operate. The Makerspace could be that kind of place. There are some substantial benefits to designating our new edition as a makerspace. One of these benefits would be to attract more students that have an interest in STEAM. As you know, we compete against the specialized public high schools in New York City. These schools sometimes draw a good proportion of the students that express some interest at Malloy. But if we have a space dedicated to allowing students to express their creativity and explore, we could offer them something that they could not have in other school settings. Furthermore, this kind of space will require both funding and assistance. That will allow us to generate collaborative partnerships with alumni, local institutions of higher education, and businesses. Having partnerships, connecting with the community, would be a fantastic result of having a makerspace, because that would allow us to, again, become more interconnected with the fabric of our local community. Furthermore, by experimenting, by venturing out and trying a new kind of classroom space, we may be stumbling upon a new way of looking at our classrooms. What if, by making more of our classrooms multi-purpose, we actually create more flexibility in our building for what kind of courses we can offer and how students use our facility? Let's take a look at a potential floor plan for this makerspace. Here's what I envision. I imagine subdividing the makerspace into 3 separate rooms, each room with its own theme. A collaborative space where students can present to each other or have conversations about their ideas, where teachers can lead discussions around creativity and exploration. In the middle, we have an electronic space. This would be a place for students to build circuits, use microcontrollers, design robots, and then finally, the third segment on the bottom would be the workshop. This would be an area that would have power tools, both larger and smaller. Students would be able to construct various devices and structures in this particular space. Later on in this presentation, I will be giving you a virtual tour. We will actually walk through these spaces, and in that portion, I will give you a few more details. So stay tuned to the end. It'll be exciting. Now let's take a look at some of the tools we will equip our makerspace with. These will be the tools that will facilitate students as they try to make their thoughts and imaginations tangible and concrete. Some of the tools will be computational oriented. Things like microcontrollers, laptops, 3D printers. Others will be for constructing and building, such as a drill press, bandsaw, and other heavy equipment. Students will also have access to smaller tools and instruments as well. Now, one of the things that comes to the forefront when we discuss a makerspace of this sort is the idea that we are giving students access to equipment and tools that, if not used properly, could be dangerous. So the question is, how do we maximize the safety in a makerspace? Here are the things I propose to ensure student safety. We will obviously follow all of the building codes and guidelines and include fire extinguishers and the proper number of exits. But in addition to that, we will have first aid kits situated around the makerspace. Also, there will be an emphasis on the close supervision of students, potentially having extra teachers in the space whenever students are making. That way, there's always a pair of eyes in each of the areas that I outlined previously. I also suggest that using a badge system could be a useful way of amplifying the safety in that space. What do I mean by that? Well, some makerspaces that I have investigated basically require their participants to receive training and demonstrate proficiency on some of the more dangerous pieces of equipment. We could employ the same sort of system in which students receive either a card or some kind of pin or something that indicates that they've received training on a piece of equipment and they demonstrated to a teacher that they were able to use it safely. Now I'd like to offer you a brief walkthrough of the proposed makerspace. We will start off in the collaborative area. You'll see that in the collaborative area we have various mobile whiteboards, we have smart boards, and we have tables and chairs that have wheels, which allows them to be shifted around the room and rearranged as needed. Furthermore, we have a space over here, what I like to call the idea nook, where students can have conversations and discussions regarding some of their ideas. All right, let's now shift around and enter the next subdivision. As we enter this room, you'll see that there are various workbenches located around the perimeter. This is the electronics space. This is where students will construct circuits and build robots. There is plenty of storage in this space for various electronic components and various parts. And you'll see across the room here we have our soldering station, and it's situated next to one of the windows, and will likely have some sort of ventilation fan to prevent students from inhaling dangerous fumes. All right, next, let's proceed into this space. What we have here is the workshop. The workshop, again, is the place for woodworking, building, constructing. Certain pieces of heavy equipment will be available, such as the drill press, and over here, a bandsaw. And in this corner, we have belt sander and a chop saw. This space will be one of excitement. It'll be noisy. It will be messy, but it will be a place for students to really explore and better understand the process of making. You'll notice that I've situated this subdivision, this room, as far as possible from the collaborative space. And that's in an effort to insulate the collaborative space from the kind of sound and noise that would be associated with the workshop. I thank you for listening to today's presentation, and I hope you carefully consider the possibility of introducing a makerspace at Archbishop Malloy High School.